Okay, so we just checked to see if we can actually communicate with the device, and we can. So we're going to go ahead and continue on with the rest of this code. So first off, we actually want to write to this one timing register to set it to maximum sensitivity. So we're going to go ahead and type I2C.write. The first input argument is the color sensor address. We're going to go ahead and copy paste that in, and then we're going to go ahead and send the next 2 bytes across. Okay, so looking at the protocol again. We've already sent the slave address, which is the first part of it. Now next one we want to send the command code or the register address value, and then we're going to go ahead and send the data byte that we want to actually write it to. So we're going to go ahead and store this into a character array of exactly what we want to transfer through. So before we actually continue on, we're going to say character data. Actually, we're going to go ahead and say character timing register. This is going to store 2 character values. And the first character value that we're going to send through is the timing register value. So it's 129. The timing register address, my bad. And then we're going to go ahead and set the value to 0. So we're going to go ahead and, so the idea is we're going to send the address first, the slave address, then we're going to send the timing register address, and then we're going to say that we're going to write that address to 0. So then we're going to throw in here timing register, which stores that array. And then we're going to say we're going to write 2 bytes, which are effectively the time register address and what we're going to set it to. And then we're going to go ahead and say false, because false means that we don't want to have any sort of repeat start condition. We just want to stop the communication from there on out. Okay, so we've just been able to write the timing register to set it to maximum sensitivity. Now we're going to go ahead and do the next thing. In fact, it's just a lot easier if we just copy pasted this in here, because it's pretty much the same thing. But instead, we're going to say this is the control register. And we're going to say the address code is 143. So we're going to say we're going to write 143 to this. And then we're going to also set it to 0 as well. And so we're going to say I2C.write the color sensor address. Then we're going to say, instead of the timing register, we're going to say we're going to write it to the control register. And writing to this one is also pretty much the same thing. So we're going to go ahead and copy paste this as well. Okay, so the enable register has an address code of 128. So we're going to say 128 is here. And this is going to be called the enable register. And we're going to write the enable register to 3. And that's going to go ahead and turn everything on. So everything's going to be working honky-dory. Enable register. Okay, so we've initialized it. And now we're going to go ahead and read stuff from the color sensor. Okay, so now that we have everything initialized, we're now going to start reading data from the color sensor. So we're going to read the clear data, which is like the ambient light, and then the red, and then the green, and the blue. So we've already had the read protocol over here, and we're just going to go ahead and just edit and change it just slightly. Go ahead and paste that over here. Okay, so again, the first thing we want to do is we want to transfer the clear data address. So in our case, our code is 148, now 146. And we're going to call this a clear register. Okay, so with that, we're going to go ahead and rewrite this not ID register, but clear register. So again, this is going to follow that general protocol where it sends first the slave address, then the register that we want to access, and create a repeated start condition. All right, the next one, we actually want to have a character array that can store 2 bytes. So a character is 1 byte of data, so we're going to go ahead and make it so that it stores 2 bytes as opposed to 1 byte. So 2 bytes, and then we're going to instantiate each of these bytes to 0. All right, so with that, we're going to go ahead and change this to a clear data. And we're not going to read 1 byte, we're going to read 2 bytes. And we're not going to create a repeat start condition. We're going to go ahead and stop and terminate the I2C communications from here. All right, so here comes the challenge of making sense out of what we just collected. So the problem is that this is what we're going to get is a 16-bit value, but we just got it in 2 chunks. So we got it into 2 bytes. So each of these are 8-bit. So with that, we're going to go ahead and work our way through with this and convert it. Shift these bits around to make it so that we can get 16. So combine the 2 bits together and make it into a 16-bit value, which is the one that we're actually going to read. So I'm going to go ahead and say int clear value, is the one that's going to store the 16-bit value. And it's going to require a little bit of bit shift operations. So let's go ahead and just explain just a few of them using a programmer's calculator. So let me just get that calculator out. All right, so we previously discussed that we can actually shift bits up and down using this little option right here. So in the case, say one of the first byte, which is the high byte, is 255. Now I want to go ahead and shift that up 8 because it's going to represent exactly the upper bits of my 16-bit value. So that's what I did. So I'm going to go ahead and shift that up. So I know that the clear data 1, which is the second value, contains the high byte. So I want to go ahead and shift this up by 8. Okay, and I'm going to go ahead and put this in parentheses just to make it so that it's a little bit more organized and the compiler is a little bit more friendly and understands exactly what's going on. The next part with that is that I want to go ahead and add my lower bits to this. So the way that you can do this is you can pretty much just plus this thing right here. But there's another operation, which is the OR operation, which is a little bit safer. So the idea is that by using OR, it's kind of like an addition, but it follows this premise of if every time it sees a 0 or a 1, it outputs a 1. If it's a 0 and a 0, it's going to output a 0. If it's a 1 and a 1, it's going to output a 1. So I'm going to use the OR operation. Let's just give you an example. So if I say OR, and I say 255, which is the bottommost bits, and I say equals, it's going to make it so that all of the output is going to have the top bits and the bottom bits. So we're going to use the OR operation. So the OR operation, the bitwise OR operation, is a single line like that. Okay, and with that, we're going to go ahead and tack on the lower bits here. All right, and there's going to be one little challenge right here because this is a character. This is a character value which contains only 8 bits. What's going to happen actually is that when I shift it up 8, all of it's going to be gone. So what I have to do is I have to typecast it into a larger value. So int, because int contains 32 bits as opposed to 8 bits. So I'm going to go ahead and do that. And so that's going to make it so that when it shifts up 8 bits, it's not going to send everything out of the storage space, memory space. So that's going to be how we get clear value. And then for the red data and green data and blue data, it's pretty much the exact same thing, but we just use a different code for it, address code. So I'm going to go ahead and copy and paste this in. Okay, so red data, so we're going to say this is the red register, and the address code is 150. Now, right color sensor address, this is going to be not clear register, but red register. We're going to make this the red data. And then again, it's going to read in the red data into the character array. And I'm going to say this is going to be red value, and we're going to do these little operations on it and turn it into a 16-bit value. And we're going to go ahead and do that with the other cases as well. This is green register. This is green register. This is green data. This is green data. This is green value. This is green data, and this is green data. I paste this one, so the last one for the blue data. So blue register, and this is not 152 but 154. This is going to be blue register. This is going to be blue data. This is going to be blue data. And this is going to be blue value. And this is going to be blue data. Good. So this code should function, and what it's going to pretty much do is it's going to store the red value, the green value, the blue value, and the clear value in each of these respective variables. I'm going to go ahead and compile this, and just to double check everything works. Okay. Everything's happy. Just a few warnings here and there, but that's just because we didn't use this for any particular purpose, and so we're going to go ahead and figure out what we're going to do with the next one with exactly these values. Okay, so we're going to go ahead and figure out exactly what we want to do with these values. So I guess the straightforward approach is we want to go ahead and just output this to a computer. So we're going to go ahead and use the serial communication link. So we're going to go ahead and at the very, very top, just type in serial. We're going to say PC, and this is a USB TX or transmit, USB RX. So it's going to receive and transmit across the USB port. Yeah, so this is a TX, RX. And then we're going to go ahead and instantiate just right in the beginning of main, or say pc.baud, just to ensure that we have it at the right baud rates of 9600. And with this, we can go ahead and just straight up just write pc.printf. I'm going to say %d, actually, you're going to say clear is going to print out this value. Red prints out this value. And just put spaces, just make it a little cleaner. G. %d, and then B, %d, and then we're going to go ahead and just type in a clear value, red value, green value, and blue value. Oh, we're going to also put a new line over here, so it's going to output every new line. So again, the idea is that each of these %ds is one of these input arguments. So clear value is going to be in this little space of %d, red value is going to be here, green value is going to be the number right here, and blue value is going to be the number right here. So this is just going to output 1. So I guess what we could also do is put this into a while loop. So with the while loop, we can make it so that it'll continuously read it'll continuously read, and we can make it so that it reads at a set rate. So right over here, when we read the data, we're going to put a while loop. So we're going to say while true, go ahead and put the last end bracket over here, just so that it'll say that we're pretty much reading continuously from here to here. And then we'll make it so that wait at least like a half a millisecond before it reads the next data value in. And so we're going to go ahead and compile this and go ahead and see what the output values are. Alright, so I just uploaded the code onto the microcontroller, and now I have CoolTerm up and set up so I can actually read out what the microcontroller is reading from the color sensor. So I'm going to go ahead and hit connect, and what do you know, it's actually outputting values. So this is the ambient light, this is red, and this is green, this is blue. And let me go ahead and just like put a purple glove on top, and it'll actually change the value. So put a purple glove on top, you're going to see it actually has changed the values. I'm going to go ahead and take it off, and it goes and resets back. And then let's say I'm going to grab just something that's my yellow what's it called sticky notes. So I'm just going to go ahead and put my yellow sticky notes on top, and go ahead and you can actually see it change value. So we got it working. This is pretty good. But the problem is like these are in numbers that we can't really a typical person can't really decipher that well. So let's go ahead and just write up some sort of code that can interpret these numbers so it output a respective color. All right, so I was fortunate to find on the Adafruit Industries webpage a processing sketch that collects the data from the microcontroller and outputs it into a color panel that goes and just shows exactly what is being detected. So if you're not aware, processing is a little app that you can download online. And what you can do is you can write code on it, and it pretty much is designed for graphics and also for like serial input. So it's a kind of a hobbyist level code where you can actually just make the computer output things. It's based on Java. So I'm currently running it right now, and here's the color sensor panel. And so I'm going to go ahead and put the purple glove on top of the color sensor and see what the color output is. So give it some time to adjust. And there you go. It actually outputs that purplish kind of gleam color. Unfortunately, the LED is very, very bright, so it kind of offsets the actual color value, but this is pretty close. What I've noticed is that it's not really good when detecting yellow. So let me go ahead and get a yellow sticky note out and put it on top. You can actually see that it kind of gets it more as a greenish sort of color, and I kind of blame the LED for that because it's very, very bright. And I can actually get something that's like a pink. So I'm going to put pink on top of this, and you can actually get the pink color pretty well. Another thing that I've also noticed, it doesn't get black very well. So what I have here is my Wacom tablet, which I use to make some of these tutorials. I'm going to put the black on top. You can actually see that it doesn't output black. And it's partly because this is a very shiny, this is actually fairly shiny, so the LED actually shines on it and actually makes it into like instead of a black and more of a grayish color. Yeah, but that's that. You can go ahead and have fun with it because I'm having fun with it right now. I'm going to go ahead and just grab something that's blue. So I have hydrocortisone cream. I'm just going to put the blue on top and go ahead and detect blue. Look, it detects blue. Great. Yeah, so go ahead and have fun. This is pretty much it. The I2C tutorial is complete. You can go ahead and play with this color sensor. Use it for whatever project you want. And we also have an available library. So instead of actually copy pasting this I2C commands, you can go ahead and use our library. We're going to publish that very, very soon. We're going to go ahead and just comment it out. So just make it so that it's very, very clear on exactly how to use it. And that'll be very, very soon. It'll be available on the mBed webpage. You can go ahead and find us.